All right, let's jump right into one of the wildest stories in all of science. It's a story that's built on a paradox, a contradiction so huge it sounds like something out of a movie. But I promise you, it's the very foundation of the world we're all living in today. Seriously, just think about that for a sec. Could you revolutionize how we see reality? Could you invent the tech that powers our entire civilization if you couldn't solve a complex equation? I think most of us honestly would say, no way. But one man's story proves us all wrong. So, on one side, you've got this kid, the son of a poor blacksmith, an apprentice who binds books for a living, with pretty much just a great school education. And on the other side, you've got the man who discovered the fundamental laws of electricity and magnetism, the guy who's literally the architect of field theory. And here's the crazy part, they are the exact same person. Now, this isn't a superhero movie. This is the real-life story of Michael Faraday, a man who many science historians will tell you is the greatest experimentalist who ever lived, period. So, how in the world did this happen, right? How does a boy from the working class of 19th century London end up completely rewriting the laws of physics? Faraday's early life wasn't about privilege. It was about poverty, plain and simple. He had to leave school when he was just 13. By 14, he was putting in long hours at a bookshop. A formal science education, yeah, that was completely off the table. But that bookshop, that turned out to be the key. You see, for Faraday, this wasn't just some dead-end job. It was a library. It was his university. So while his hands were busy binding books, his mind was just devouring them. He read absolutely everything he could get his hands on, especially science books. And he started to see the world differently, not just as words on a page, but as a place full of hidden principles and invisible forces. And you have to appreciate the sheer guts of his plan. He didn't just go to some lectures by the famous Humphrey Davy. No, he created the ultimate resume. He took 300 pages of perfect, detailed notes, bound them himself into this beautiful book, and then mailed it to the most famous scientist in all of England, basically asking for a job. And you know what? It actually worked. Davy was so blown away by this young man's passion and his attention to detail that he gave him a job. So at 21 years old, Michael Faraday just walked through the front door of the most important scientific institution in the entire country. And his life was never, ever going to be the same. So, okay, he's in the lab. He made it. But he's still facing this massive hurdle. The language of physics then and now is math. And that was a language Faraday barely spoke. This is maybe the most important part of his story. Faraday couldn't just whip out complex formulas, so he had to come up with a totally different way to think, a different way to see the world. Instead of equations, he used his intuition and this incredible ability to visualize forces. And here's the kicker. What everyone else saw as a huge weakness, that was actually his secret weapon. He developed this amazing, revolutionary idea he called lines of force. He imagined that the space around a magnet wasn't empty at all. No, it was filled with these invisible lines, a physical field of energy. He could almost see them, like invisible tensions in the very fabric of space. For most scientists at the time, this sounded, well, it sounded pretty weird. And yeah, some people just dismissed his picture thinking, but others, the really smart ones, they saw the genius in it. Decades later, the great physicist James Clerk Maxwell, the guy who would eventually turn Faraday's ideas into the famous equations of electromagnetism, said this about him. He understood that Faraday's intuition wasn't a lack of math, it was a different kind of math, a visual, physical way of understanding how reality actually works. And this unique ability, this way of seeing the invisible, led him straight to the discovery that would literally light up the entire planet. For an entire decade, Faraday was obsessed with one single question. Everybody knew that an electric current could create a magnetic field, but could it work the other way around? Could you use a magnet to create electricity? For 10 long, frustrating years, the answer kept being no. And then, he had the breakthrough. He finally realized the secret ingredient wasn't just having a magnet, it was change, it was motion. When he moved a magnet through a coil of wire, he imagined those lines of force slicing right through the wire. That simple movement, that disturbance in the invisible field, that's what pushed the electrons along and created an electric current. He had just discovered electromagnetic induction. Now, that may sound pretty basic, but just look. Look at what this one discovery led to. This isn't just some list of inventions. This is the blueprint for our entire modern world. The electric generators that power our cities, the motors that run all of our industries, the transformers for our power grids, it all starts right there in that moment.
I mean, just let that sink in for a moment. That instant of discovery in a London lab back in 1831 is directly connected to you, sitting here right now. The power running through your phone or computer, the lights on in your room, it's all a direct result of Faraday's beautifully simple experiment.
So, what's the ultimate legacy of this man who could see what nobody else could? Well, it's actually even bigger than all the amazing technology he helped create. This slide shows it perfectly. It was like a partnership across time. Faraday built the conceptual foundation. He gave us that deep, intuitive picture of what was really going on. And then James Clerk Maxwell came along and built the mathematical structure on top of that foundation, giving us those elegant equations that tied together electricity, magnetism, and even light. You just can't have one without the other.
And hey, don't just take my word for it. Albert Einstein himself said that the work of Faraday and Maxwell was the biggest shift in how we understand reality since Isaac Newton. They didn't just find a few new things, they gave us a whole new universe to explore.
So Faraday's final lesson, the big takeaway, is this. Genius isn't just about what you know. It's not about how many formulas you can memorize. It's about how you think. It's about having the curiosity to ask those huge questions and then having the imagination to see the answers that are hiding right in front of us. The world that Faraday gave us is built on his ability to see those invisible forces connecting magnetism and electricity. So that leaves us with this one final, really inspiring question. What unseen connections, what invisible fields and hidden relationships are all around us right now, just waiting for the next person with the courage to imagine them?